Okay, so this one says to derive an expression for the worst case propagation delay for this full adder, and assuming XOR and OR gates have a propagation delay of Tx and To respectively. So we want to figure out what the worst case propagation delay is. Now, you could have your propagation delay depends on whether things change. Because if nothing changes, then you don't have to wait for this AND gate to do its thing. If the result that you get here is the same that you had before, and if the result that you had here is the same that you had before, then you don't have any additional delay. But we're going to assume worst case scenario that every time something is going to change and we're going to have to use the full time of each of our gates. So we want to identify little not sub areas, but stops along the way. Okay, so we said that the time for an exclusive OR was Tx. So the time for this exclusive OR is Tx, and that's also Tx. The time for the OR was To, and it doesn't say and so I think this is just a mistake, that it also should have said that the propagation delay of XOR and the ANDs would both be Tx. So the propagation delay Tx also for the AND gate. The other thing that you could do without saying that is to say that it doesn't matter. We're going to say that the exclusive OR is always longer than the AND, in which case that we'd always be using the Tx anyway. But we'll just say that, but that's just because in the way this particular one is set up. So we're just going to say these are also Tx. Okay, now I'm going to call this location U, and I'll call this location W, and I'll call this location V. So those are all of the kind of stops along the way. Those are all places you have to get to before you can go on to the next step. So you can't get to this gate until you've gone through this one. You can't get to this gate until you've gone through this one. You can't get to this gate until you've gone through this one. So the time at U, and we're looking at what the maximum time would be, is going to be, now we assume that wires have no time. So it would be the maximum of the time for this signal and that gate, but we assume the wires don't take any time. So the time at U is just Tx. Similarly, the time at W is, oh no, he does change it here to A. He just writes it X somewhere different. So we'll call the AND gates A, sorry, TA. Okay, so the time at W is TA. Okay, so now let's look at V. These two signals are this first signal that is coming from CI up above. So that's what's coming into that AND gate. And the second signal is the signal that's coming out of this first exclusive OR. So CI, we're going to say that takes 0 time. So the time at V is going to be the maximum. So we have two things coming into it. It's going to be the maximum of either just the signal C and U, and the maximum of those is going to be U, because C doesn't take any time. So the time at V is going to be the time of U plus TA. The time at U we said was Tx, so this is Tx plus TA. So now let's look at the time to get to S1, the time for S1, or SI, the time for SI. So the time for SI, that's the exclusive OR of C, which we say takes no time, and U, which we said was time Tx, plus we have another Tx there. So that's going to be the time at U plus Tx, which is Tx plus Tx, which is 2Tx. And the time for Ci plus 1 is going to be, so Ci plus 1 has two inputs. It has V and W. So we would need to see whichever one is the maximum of V and W if we're trying to get our worst case scenario. So the time of at Ci plus 1 is the max of the time of V and the time of W, plus the time of an OR gate, and this is the max. T of V was Tx plus, sorry about my bad handwriting, Tx plus Ta, and Tw was Ta plus To. Well, the max of Tx plus Ta and Ta is Tx plus Ta. Sometimes you don't know what the max is. Sometimes this would be like a Tx and a Tz, and you have no idea what the max is. But given the choice between Tx plus Ta and Ta, you know which one is bigger. So Tx plus Ta. So this is Tx plus Ta plus To. So we have two outputs. We have Si and we have Ci plus 1. So what is our maximum propagation delay? It's the max of 2Tx, which was our time for Si, and Tx plus Ta plus To. And we don't know which one of those is bigger, so we can't say which one of those is bigger. So that's our answer. It's the maximum of those. So any questions on that very exciting problem? Because I can see that everybody's like, just like enthralled. It's like, oh man, I wish we could do more of these.
It's my favorite.
Yeah. All right. So let me save this one.